Welcome friends, welcome once again in my YouTube channel. This new video is going to talk about how do we do ducting for HVAC systems. HVAC system needs ducting to transfer the cold air from one place to another place to have proper distribution of air, cold, filtered or air conditioned air as I say, and ducting plays very important role there. Now traditionally we have been doing ductings with various materials, and today in this video I'm going to talk about what is ducting, what are the standards for ducting, and what are the good practices for installation, because it plays very important role. So let us jump into this video, and the name of the video is Good Installation Practices HVAC, and we are going to focus on part of ducting. As I said, ducting is a medium through which the air distribution happens from the air handling units, from the fans, or any air moving apparatus is connected to the particular area by means of ducting. Now, air which is being at source of fan or air handling units or maybe an FCU, that air has to be transported to multiple places depending upon the layout of the ducting. Now, when we do this, we have to ensure that the ducts are leak free. It cannot be 100% leak free, but minimizing the leak in the ducting is very important. And for that, understanding of concept of ducting, what are the standards of ducting and what are the good installation practices of ducting is very important. So this aspect of the video is going to look at a little deep in the ducting, and I hope it will add value, because in my experience, whenever I ask questions about ducting, people only tell that we give the sheets or the fabricated ducts to a ductman and he is the person who knows everything about ducting. But as an engineer, it is our responsibility to know what is ducting and get it installed in a right manner so that we get the benefit of the air transportation or air distribution, an important aspect of HVAC system. Let us look at this, and if you still feel there are some things which I should cover, I'll be glad to cover that. Before I move ahead, I request you to subscribe my channel, like it, and give your valuable comments. Now, let us start first of all understanding of standards of fabrication, how the ducts are fabricated. Now, this is with respect to the GI ducts. We generally use galvanized sheets for manufacturing or fabrication of ductings. Generally, it is 120 GSM, that is the thickness of the zinc coating. It can be 180 GSM, it can be 275 GSM. But before you start any work at site, this sheet is very important, which has project name, which has got site locations, which has got a reference or whatever you want to add on top of it. But the important crux here is we should know, depends on your specification. This is one of the sample, a specimen. It cannot be applicable to all the project sites, but you can make this kind of sheet which is very clear to everyone, right from the workman to the manager. So what it has is, it has a serial number here, it has a duct size, which is the duct size, what is the gauge or thickness of the sheet which we are going to use for duct size, what are the transverse joint, the flange joints between the two ducts, which kind of joints we will have, what are the joint reinforcement. So when we connect a duct here, the duct becomes leak because there is a joint, right? Anywhere there is joint, it will have leakage. So are we going to strengthen the joint by having some means? That is called joint reinforcement, intermediate reinforcement. Earlier we used to have ducts of 8 feet, and when you have higher length of ducts, we need reinforcement to get the stability of the duct, because when you manufacture ducts in rectangular shape for over length, it has to be rectangular across the length, and for that we need intermediate reinforcement. Even if you now start manufacturing the 4 feet ducts, depending upon the size and the pressure, we will have to have intermediate reinforcement. If there is an bracing required, what is the kind of bracing, and what is the longitudinal joints across the joint? I am sure that everybody will know this. So what are those joints which are required to complete ducting? So this can be a kind of guide. Longitudinal joints will give you clarity of longitudinal joints and all other reinforcement and transverse the flange joints will give you clarity. So this is very important thing before you move ahead of that. Now, this is similar thing. It is done in a little different way, but this gives clarity on what it is. So if you can see here, a transfer joint spacing is 1.2 meters, that's 4 feet, and that's what we generally get. This is the duct support. How we are going to handle the duct supports for different size. Now, if you look at the sizes over here, these are the size of duct. Aspect ratio is here. The duct perimeter we get depending on the gauge we have. Gauge in, if you convert it to mm, we will have this. What is the support span? That's very important to look at. What is your tender specification? It is 2.4 meter or it is different. Look at that, right? We have seen what are the joint reinforcement and the reinforcement at the intermediate level. Based on this, we can get the weight of a duct. And whenever you must have seen the ducting which we do at site, we always find that people are sitting on it, people are working by standing on it or sitting on it. That's not the right way of doing it, yes, but we have to consider unexpected load of someone sitting on it just for the calculation, not for doing it. Please don't take it otherwise. Ducts are not meant to sit on it and do some work. However, while calculating the supports, we get unexpected load of one person, which is considered here 74 or 75 kgs. We get total load, and from there you can get from SMACNA standard what is the hanger size. The hanger size, the threaded rod, whether 6 mm, 8 mm or 10 mm. We can also get from SMACNA what is the bottom angle which is required to support that duct depending upon the weight of the duct. So it's very important to know this. So we have seen what is the duct construction and we have seen what is the duct supporting. That's all. If you know this, you are through, and you should be confidently telling to whoever asks question about this. Many times in interviews, this is missing. Let's look at what is the construction of duct. Now it looks like this. This is the duct. It looks finally, but it has, as I said, this is a flange joint, and flange joint in SMACNA standard, now we use these corner pieces which has got a hole which is for nut bolting. So this is called 4-bolt system, right? Now this is at the corner. This comes from factory, which is the flange. So this flange in which we insert this connector and we complete the duct like this. After that, we put a gasket. So this is a gasket. The other side of duct is prepared similarly. This is a flange. Then we have this duct connectors, duct joints, which are the 4 bolts joints, and then we get ducts together. And to hold this duct together, we use these clits. These are called clits, which are fixed on at 150 mm or 300 mm distance, so that ducts are secured properly. And ducts are not opened, because if the duct length is high, duct length is more, the joints can get opened, because it are only bolted at 4 places, and that's why chances of opening of the duct is there. So these clits are used. Now, as I said, this is the joint reinforcement. This is a joint, and this is where the reinforcement comes here. Now, depending on duct size and standard which you use, this will vary. Generally, now from the factory we get a groove inside the duct so that it becomes a little stable. Then this is a intermediate reinforcement. Now again, based on our charts, we can select what kind of reinforcement is required. So as we have seen in the chart, this gives a clarity. So I hope it is clear. It is very important to check which standard we are using the ducting. There are SMACNA standard, the DW standard, this IS standard, right? We have to first of all know and make the chart accordingly, which I have shown you. After that, when you fabricate the ducts at site or from factory, and when we assemble, we have to assemble it properly. We have to do a duct supports marking. We have to first then hang the hangers, put the ducts in, remove the collars. Collars should not be on elbows or taper. Many of find, I will show you some of the photographs, the collars are taken at the elbows. Remember this point, I will show you the photograph later. It is important to note that we need a proper grid work so that my branch through which the finally air will be distributed to the area is connected properly, and there is no gap between the false ceiling and the branch. Otherwise, what will happen? The air will start leaking over the top of the false ceiling. The required air will not come down. So your false ceiling will be cooler than the area temperature. It is important, as I said, the droppers of branches are terminated right at the end of the ceiling. Whenever there are elbows, we have to ensure that vents are there. Vents will guide the flow. Otherwise, there is a lot of disturbance, and again we'll have pressure drop, and the air will not reach to the places. You have to see all the ducts joints are sealed with sealant, and we have to do a proper leak test. Now, how do we store the ducts? These are the ways of storing the ducts. Generally, duct which comes from factory will have identification, which will be easy for you to segregate the ducts. What are the material which I said is required to do a complete ducting? So we said with GI sheet, or that GI sheet can come to our site and we can get it fabricated at site, or we can get a factory fabricated ducting. We cannot do 100%, something has to be suited at site. That's why GI sheet comes. We also use flexible ducts for various purpose to connect the main duct with respect to the collar. Then we have a VCD, that's a volume control damper, which controls the air. So it's a damper which is inside the ducting. Use anchor fasteners. Sometimes when the ducts are required to be treated with fire treatment, we do that fire treatment. And there are a lot of other accessories, like as I said, about clear gaskets, nut bolts, supporting material which is required, fasteners which are required to hang the ducts. So these are some of the list of equipment. We need drill machines, we need air leak test machine, we need measuring tapes, plumb, spirit level, laser level is common now. We need hammer, Allen key, fasteners, punch tools. These are all required equipment to complete the ducting. How do we do this ducting? First we mark the supports, and then we drill the supports and we go for fastener installation. That is a bullet type fastener which goes inside, which has got thread outside and thread inside. So the threaded rod goes inside and stucks. The outside parts goes into the slab and gets properly fastened. The inside part has thread which has the provision to get threaded rod fastened there. Then we install these ducts like this. So as I said, this is a threaded rod which goes into this fastener. The fastener is already inside, which is got internal threads. Then we have supports based on these specification. Then we do the acoustical treatment of the duct wherever required, and then we install the ducts. We seal these joints. These are all CNS type of joints. We do the supporting properly, and finally we do the air leak test. Now, based on the specification, whether 10% is allowed or 20% is allowed, you have to take a call at site depending upon project to project. Then once the ducting is done, we insulate the ducts, and finally we cover the joints and use the insulation to cover the joints. This is how the ductings are done. Now, another factor is we need to also have identification with which ducts carries what type of air. It's carrying treated fresh air, it's carrying exhaust air, it is carrying only outside warm air. It depends on, there are identification marks and the color coding which is given in the standards which have to use. This will help us in identifying the ducts even in future. As I said, grid work is very, very important, and this is one of the good example of getting the grid works. We can see all these where the collars can be properly terminated. Otherwise, there will be loss of air. Otherwise, you can see the bad part of it. Look at the grid work and the kind of collar. They are sometimes out, sometimes in, and there is no proper workmanship. It's total chaos. I don't blame the only workman, the supervisor who are carrying that job are equally. These are some of the important things which we can help in expedited ducting wherever the support is not possible, the slab is not there. There are a lot of beam clamps or purlin clamps are available in the market which will help in expediting the ducting. These are some of the tools like collar cutter. We generally use that screwdriver and hammer, which gives a crooked way of doing that collar cutting. This is a perfect tool which can give a smooth collar cutting, and it can also, because if you try and take out a collar for suppose 600 by 150, how much time it will take to do this screwdriver, hammer and cut? It will take a lot of time, but with this we can get in minute. Productivity also can be improved. We can get the plumb meter to find out, instead of spirit level we can get plumb meter which will give proper alignment. Seam locks, all these longitudinal joints, Pittsburgh or all, this can be easily done at site, very, very fast, other than putting hammer and using a manual effort. This can save a lot of time. These all equipments are another safety angle is very, very important. All equipments are safe to use, right? So if you use the hammer and if you hit on by mistake on your fingers will get injured. You can get a laser guide which can again give you a proper marking. You don't have to go and physically mark. This will properly set you. This will give you around 20 meters this side, 20 meters that side. Proper marking. You can easily go and do the drilling and fastener. Rebar locator, most of the time the slabs we find while drilling, we find there are rebars, so we have to adjust. Again, we have to go adjust. Trial and error method. Rebar locator can give you a location of the rebar so that you avoid drilling and save time. Power drill, this is wireless drill, very efficient. Safety, because most of the time the drill machines are put without pin top. Most of the wires are cut. Sometimes they are joined with sellotape. All these kind of things happen. This doesn't require pin top or power. It's a battery operated. You can do your work very faster and safer and with a lot of quality. This is what another picture which I want to share you. This is how the ducting is stored, and I have shown you the pictures earlier how it has to be stored. These are some of the good way of doing the work. You can see a proper scaffold. You can see this the collar cut. It's very smooth, very fast, right? This is the example which I was talking about. Taking collar from elbows. This will not have air any point of time. Look at this collar here. This collar is taken at the joint. The joints will be weak here. So these are some of the things which at site has to be alert and guide the workman to do a proper job. Look at here. This air is not coming here. So they have removed the core of the diffuser. That's not the way to do it. This is good way of ducting, using a proper supporting. You can see proper supporting, a proper alignment. You can see use of a duct lifter to avoid manual lifting. This will also help in a big way. This is one of the duct lifter specification. Use of proper equipments like scissor lifts, like boom lifts, boom lifts to expedite your ducting. You can see the good way of ducting which is done over here, and you can see the crooked way. Another examples. This is the finished one which we see from outside, but what goes inside no one knows. It's only the supervisor, the workman will know. So it is important that what goes above should also be done properly. This is how people use our ducts. Most of the places they are using, you can see here, to support the cables, and this is where the alertness of site supervisor is very important. Look at the ducts over here. You can see now here I can just explain you. This is a joint, and this is not a tedious joint. This is the joint reinforcement. Even if there are grooves over here, we have added joint reinforcement over here. This is the you can see intermediate reinforcement. You can see the kind of material which is being used and how ducts are properly installed. See this reinforcement joints. You can see proper bolting which is done, proper gasketing. Now here is a rod. Now since this duct is big size, this we cannot have one fastener which will take care of this load. There is a chance that this fastener may fail and this duct can come down. So what is here done here? There are two fasteners which are used over here, and from there is a C channel over here which is pushed inside with two fasteners, and from C channel we are taking support here. So this is how the ducts can be constructed, installed, which is a good way of doing the ducts. This is another picture which shows how beautifully the ducts are installed. Another good looking ducts. There are circular types of ducts also, or elliptical ducts. These are some of the examples. How do we protect the ducts? In IGBC, in green building projects, it is important to make sure that ducts are dust free, or anything which is dust free. How do we protect that? Do we protect? We don't. It's important to use the right kind of material to protect the duct. Otherwise, what you will get is this: all the ducts will be inside with a lot of dust, and this will finally come at your the air terminal level, or you can see this kind of picture, false ceiling, and this generally will carry a lot of bacteria which can also spread diseases. Very important to make sure this. Pre-insulated ducts are coming in market now, which is the pre-insulated boards. There are different manufacturers, different standards are available now getting popularized. You can see some of the pictures over here. These are easy to make, and we can save one of the important activity of insulating the ducts. These are some of the examples. Flexible duct, as I said, which can be used to connect a collar or dropper and main ducts. So it gives the flexibility of installing your dropper nearby, so that you don't have to put a rigid collars, and then a lot of rework can happen. But look at this, how the ducts, these ducts are used. These are not the way we should be using these flexible ducts. The air will not reach. First of all, the length of the flexible duct should not be more than 1 meter. Otherwise, the pressure drop will happen and you will not again have loss of air. This is the correct way of doing the installation. You can see over here, this is a duct, this is a hanger, this is a flexible duct. It is connected with proper tie rod, and it is connected here properly, and this is how both are supported. So this is how flexible ducts are installed. Another important part is fire damper installation. We do a lot of different kind of installation. Now look at here, there is a wall which is a fire rated wall here. Fire damper is here, and this is the sleeve of the fire damper. Now this fire damper is connected to a duct by a slip joint, because in case of fire we have to ensure that fire damper remains. So even if duct goes out, it is okay, but if you make it rigid, it will take sometimes the fire dampers also along with it. So these are the slip joints which we use over here. How do we retain the fire damper? For that we have a retaining angle. So this retaining angle is having bolted to the sleeve. It is kept alongside with the walls. Now what we do with this? We put a fire sealant in bit to avoid passage of fire from one side to another side. We also provide, in case of visible link, access door, so that people can easily go and do the work at visible link. So this is how fire damper installation is done. As I said, these are various color coding and the fonts which are used to identify the ducts: conditioned air, hazardous air, dirty air, outside air. You can use this to make sure the ducts are identified properly. IS standard on the right hand side, DW standard in the center, and SMACNA standard. These are popular standards which are used. I request you to go through these standards to get more clarity. This is a checklist which is again a sample. You can drive your own checklist. How do we do the duct? We should do a mock-up. We should always ensure a drawing. Which kind of ducts we are going to use, what are the duct joints, what is the duct alignment, gasketing, the collars are taken properly or not, the provisions for probes, bracings, VCDs, all these are properly checked before it is given for false link clearance. So this is very important checklist which I thought should bring out. So I hope I have covered majority of the aspects of ducting, and I request you to implement this. It will add value. Thank you very much for patient listening. Please follow me on YouTube, Facebook, and LinkedIn. Thank you very much.